stress, and we said that stress was force divided by area, and the unit that it turned out in was a Pascal. Okay, and that was a measure of how much was going on inside the material when you put a particular force on a particular area. What I want to do in this video is ask the question of how much does that change? What happens when something changes? So if we squash something, how much does it change? And we're going to just measure that really simply by delta L. Okay, so remember that old triangle is always changing. So this is change in length. Okay, and that's going to be measured in meters. It's an M. It might not look much like an M, but it's an M. So it's the change in length in meters. So when I put a force on something, it changes length by a millimeter or 0.001 of a meter. So I can actually measure how much it changes length. When you think about it, that's not actually that useful piece of information. I mean, ultimately, it's often what you need if you're doing design work. You want to know, if I load this up, how much is it going to change in length by? But if I tell you something changes in length by 1 millimeter, and you say, is that very much? Well, if I started with something that was 10 millimeters long, and I squashed it and it changed by 1 millimeter, that's quite significant. But if I started with something that was 10 meters long, and squashed it and only changed by 1 millimeter, that's quite different. So thinking about the change in length just as a number sort of only gives half the picture. We also really want to know what the original length was. So we're just going to use L for original length. Also in meters. And then we want to be able to compare those two things. And what we're going to do is we're going to introduce a new idea, which is strain, and the symbol we use for that is a curly E. It's actually an epsilon, but it's another one of these Greek letters. So strain is equal to change in length divided by length. Okay, so it's a comparison of how much something changes compared to what it was at the start. Okay, so let's have a look at an example. So we're starting with something which is 576 millimeters long, and we're going to apply a force on it, and when we apply a force on it, it's going to squash down by 12 millimeters. Okay, so this is still the same thing. So when we've squashed it, it's changed by 12 millimeters. And the question is, what's the strain? So all we have to do is strain is change in length over length. So the change in length here is 12 millimeters over the original 576 millimeters. Notice the units are the same. As long as they're the same, it's okay. You can't have 1 in millimeters and 1 in meters, or 1 in miles and 1 in millimeters. That would be really stupid. Okay? But you've got to have them matching units. So as long as the two units are the same, then you're okay, which means that your answer is going to be unitless, because they cancel out. So strain has no units. Okay, it's just a number, it's a ratio. It doesn't have to have a unit. So let's do the calculation on 12 divided by 576 equals 0.021. Okay, so all we've got is a number, and it's a reasonably small number, and that's quite typical. So this is a couple of percent. And that's all we're going to measure for strain. So it's a measure of how much something compresses or stretches, if you're doing a tensile test rather than a compressive test, how much it stretches or squashes compared to its original length. And that's all we mean by strain.